Welcome back to the video, and today we're going to solve Laplace transformation using a tabular table. So this is our first problem. So it's f of t equal to 4 sine of 3t minus pi minus 3 cos 2t minus pi over 2. From here, we can use your trigo identities. So let's start with this. So 4 sine of 3t minus pi is actually your identities. So this will expand. Okay, this actually is your, so this is 4 times your, so this is sine, this is sine 3t times your cos pi minus your cos of your 3t sine of pi. Okay, so sine of pi is actually 0, so everything here is 0, so we cancel this out. So but cos pi is equal to 1, so it's equal to 1. So what's left is your sine 3 of pi. Oh, sorry, it should be negative 1. So what's left here is your negative 4 times sine 3t. Now for your 3 cos 2t minus pi over 2 is also another triangle identities. So expand this, so this actually is your cos 2t cos of your pi over 2 plus sine of 2t sine of pi over 2. So cos of pi over 2 is 0, sine over pi over 2 is actually 1, so 0 cancel out, and what's left is your sine 2t. So this is actually your 3 sine of your 2t. Okay, now let's put it together. So we have here negative 4 sine of 3t minus pi, 3t, okay, minus, we have here minus your 3 sine 2t, your Laplace symbol. Okay, so we distribute the Laplace symbol. So from here we did to count to 4, and here your Laplace of sine 3t, okay, minus your, this is your 3 Laplace of your sine 2t. And from the table we can have here your s or your a over your s squared plus a squared. So this is your negative 4, so your a here is your 3 s squared plus your 3 squared, so this is 9, minus your 3, so this is again your a all over your s squared times plus your a squared, or this is your 4. Okay, so simplified further, we get your negative 12 all over your s squared plus 9 minus your 6 all over s squared plus 4. This is our next problem here. We have your sine raised to 2 3t times your cos squared of your 3t. So what I did here is I used this triangle identity, cos 2x equal to, the first one is 1 minus 2 sine of 2x, the other one is cos 2x equal to your 2 cos squared x minus 1. Okay, so simplify these further. So here we have your sine x squared, okay, equals to your cos, your 1 minus cos 2x. So divide this by 2. So what's left is sine squared x equals to 1 minus cos 2x all over 2. This is for your sine. And now for your cosine, we use this. So let's move 1 to the other side. So what's left is 2 cos of x squared equal to cos 2x minus 1 divided by 2. We get here cos squared x equal to cos squared x, cos 2x minus 1 all over 2. This we're gonna be putting here. Okay, so let me erase. So the Laplace of your 1 minus cos 6t all over your 2 times your cos 6t plus 1 over 2. So we multiply them. You get here 1 minus cos 6t times your cos 6t plus 1 all over 4. Again, we simplified here further. We distribute, and what really turned out here, it just goes back to your sine squared 6t all over your 4. And we know by basing on this, what we did previously, so this will become your 1 minus cos of 12t all over your 4. So we took out a constant, so it's become 1/4. L with the plus of your 1 minus your Laplace of your cos 12t. So your Laplace of 1 is equal to 1 over s. So this become 1 all over your 4s. And here we get here the Laplace of your cos t is equal to s all over your s squared plus your squared of your 12. So 12 raised to 2 is 144. Okay, and this will be your final answer. So I forgot here 1/4. So this will be your final answer. Okay, this is our next problem. So it's f of t equal to cos 3 cos 4t times cos 3t. So there is actually a triangle identity for this, for cos x times cos x. So the Laplace, so we took out the 3 first. Yeah, let's look at the 3. Okay, so this actually transforms into a cos 4t plus 3t. Okay, cos times cos of 4t plus 3t plus your cos of your 4t minus your 3t all over 2. So we took out again the constant here, so this become 3 halves of Laplace. So I have here cos, this become 7 of t, put parentheses here. Then we have plus a Laplace of your cos, this become your t. Okay, now we have 3 over 2 multiplied by, so cos, again cos x is just s of your s squared plus your 7 raised to 2. So that's 49. Okay, then we have here, plus cos t, so this will become s all over s squared plus 1. And this will be your final answer for your number, or for your letter C. And this is our final problem. So I have here 10e raised to negative 0.5t. So you notice here we have here a parenthesis, meaning they are all raised to negative 0.5t. So we treat it as a, and we treat this as a t. Okay, now there's actually a table for it. So we just here the Laplace of your e raised to ln of your 100e of your negative 0.5t. Okay, then from here we know that your Laplace of your e at is just equal to 1 over your s minus a. So just copy this. Okay, it's very similar. So we have here 1 all over your s minus your, so we're gonna move negative 0.5 to the front. So negative 0.5 times your ln of your 100e. And we simplify it further. So you have 1 over s plus 0.5 ln of your 100e. And this will be your final answer. Today I learned about Laplace transformation using the tabular table. It's much easier than doing the integral style, and plus doing the trigo identities is much easier also. And I hope I can use this in my board exam and my exams. Thank you for watching, and see you in the next video.